management. Today we're going to talk about picking winners in March Madness. So if you see my talks in the past couple of years, I come here and I give you some algorithm like play fantasy sports, DraftKings, whatever. So today is the same kind of theme. We're going to give you an algorithm that actually works to win March Madness. And this is the work done with my student Sean Chow, really smart kid. So me and him put this stuff together. This is the clicker, right? All right. Yes. Okay, so March Madness. So what is it? We all know what it is. 64-team tournament, 6 rounds. We all go crazy in March for it. That's why it's called March Madness. So we're gonna build brackets to win this competition, okay? And to make a really concrete goal, my goal is to win the ESPN March Madness competition. So that's a competition of like 25 or 28 million people, right? You put in your brackets, and then if you beat them all, you get like, not that much money, like $50,000, which is, I mean, that's a lot of money, but like, you're beating 25 million people, right? So it's not that much money for me, but it's the principle. Like, I want to win it, just to like show I can win, right? So, like I said, I don't do this for the money, right? I do it just to do it. So we're gonna win this competition. That's the goal today. All right, so yeah, picking winners, how are we gonna do it? So our approach, we're gonna enter many brackets, okay? If you saw my DraftKings talks, we entered many lineups to win those contests. Same thing here. We're going to enter many brackets because if one bracket wins, I'm happy. Okay? So I got to get one bracket to like cross the finish line and win. And we're going to use the exact same ideas from the DraftKings stuff and just apply it kind of here, like out of the box. Like it's so trivial. Like once I did it, I was like, oh, that was so easy, right? So we'll apply the same principles here. So this is the object we're going to construct. These are brackets. We're going to build these things. 64 teams, 6 rounds. What you're going to pick in a bracket, you're going to pick which team is going to win in which round. So like Michigan, right? So I'm from Michigan. My uncle's a professor there. So growing up, I adopted this team. Also, I like Wolverine, my favorite X-Men, so Michigan. But if for Michigan, right, I got to pick if they're going to win the first round, win the second round, like when are they going to lose, right? That's basically what I'm picking in a bracket. So if that's what you're picking, I can describe a bracket mathematically, right, MIT, analytics, with a matrix. I call this matrix B for bracket, and it's 64 rows, right, and then 6 columns, and every B, like B22 means team 2, maybe that's like Gonzaga, wins in the second round, make that a 1, right? Or B2, B64-6, maybe Xavier, right, wins the finals, so they make B64-6-1. It means they get to the 6th round and win it. Okay, I got to pick them 0s and 1s. Now, this is what's called a binary matrix because all the numbers are like 0 or 1, right? Binary. But not every matrix is okay. Like some of them ain't proper brackets, right? So I got to respect the rules of the tournament. So some of the rules are, once you lose, you can't win after that, right? So going down the row, it's like 1, 1, 1, 0, 0, 0. You can't go like 1, 1, 0, and then a 1. Like once you're out, okay? So mathematically, there's that inequality there. So all you dorks out there, we're at Dorkapalooza, so Bill Simmons said, yeah, all you dorks out there, get out your cameras. That's the inequality for that constraint. Okay, take a picture of it and write it down. The next one is like what I call the block constraint. Okay, so the tournament can be thought of as like a bunch of blocks. So for instance, 1-0 there, that's the 1-0 block. It's like round 1. Block 0, there's 2 teams in that block, right? Team 1, team 2. There's only one king of the block, you know what I'm saying? So like either 1 wins or 2 wins, but they can't both win. For like 2-0, that's round 2. Block 0, the teams are 1, 2, 3, 4, right? Only one of those teams is gonna win that block, okay? So you got a constraint like that for every single block in the tournament. And this is the trickiest one to write down, but I sat down for like an hour and did it over the summer. That's the equation for the block constraint, okay? Like everything I told you is now one line there, so take a picture, write it down, that's the inequality, okay? So now we got no winning after losing, only 1 king of the block, so now we have a feasible bracket, okay? And now I don't want it as feasible, like feasible is what like losers do, but I'm a winner, so I want to have a good bracket. And a good bracket has a lot of points, okay? Now in the ESPN tournament, many other tournaments, you get points per round. So you pick a winner in a round, like in round 1, you get I think 10 points, and 20 points, 40, 80, 160, something like that, right? But there's a score per round. So that's for a score per round. So multiply the score for the round times the element in the bracket matrix. Because if I pick that team to win that round, right, I'll get those points if they win, okay? Now, I don't know if they're gonna win, right? So let me maximize not the actual points, but like the average points. So then stick in there a probability that team T wins round R, okay? And here's like the tricky part. Like, what is that probability a team wins in that round, right? Okay, well, let's call that thing Q, right? I'll call that Q because like that ain't the main probability of the problem. That's like a derived probability. The more fundamental probability, like the atoms of March Madness, is what I call the P matrix, which is PIJ, means team I beats team J. When you make projections, you're probably thinking like, okay, Michigan and like Villanova, I think there's like an 80% chance Michigan wins, right? That's like what you build your projections. And then from that, you can derive all the Q stuff, like in the tournament, who's gonna win what, okay? So how do you build the Q from the P, right? Well, there's a recursion for that. I'm gonna show you that in a second, okay? Now, how do you get P, right? Well, you can use many like off-the-shelf models, like the ELO model works well, something stupid like that. Or just buy the model, like ask your friends, like make you a projection matrix, buy it from them. That works too. That's how I play DraftKings, by the way. I have a guy like get paid money, looks at projections, I just enter them, okay? And then you just take in the P, run the recursion, and you get out the Q, okay? Now, if that is too much for you because you're just too lazy, okay, just holler at Nate Silver, 538 makes the Q matrices, you can just get their Q matrices or some lucky Q matrix, right? So holler at Nate, get his one, or if you win, make your own one, that's what I'm gonna do, okay? All right, so how do you get the Q from the P's? Well, it's kind of easy, like first round, okay? The Q is essentially the P. So the Q for Michigan round one, it's just a probability Michigan beats their opponent in round one. Feel me? That's easy. The next round, like round two, well, Michigan wins round two if it gets to round two, which means they won round one, so that's Q1 for Michigan, right? Then they got to meet their opponent there, so the opponent got to get there. So there's like, you know, two other people that could be in the second round. So though they're Qs to get there, and then multiply it by the probability Michigan actually beats those people. So it's like Michigan's Q, then add up Q times P for all the opponents in that round, okay? It's kind of messy there, but trust me, it's easy to write down in computer code, but take a picture if you want to like do it on your own. Anyways, once you give me the P, I do this thing over and over again, and I have all the Qs, okay? And I have the Qs, and now I'm ready to roll. So there's my objective function, just maximize that. That is average points of my bracket. Respect the constraints, right? No winning after losing, respect the block, let's roll, okay? Well, we can't roll quite yet, because when I roll deep, okay? Not one bracket, not two, I'm talking 1,000 brackets, okay? I roll 1,000 deep, like Meek Mill, right? That's how I roll. So what I'm gonna do is, I'm gonna make the brackets one at a time, okay? One at a time, make a bracket, say make it feasible, maximize the points, but just make it different from the last couple of brackets, okay? What does different mean? Well, if I take my bracket that I'm making now, and I take an old bracket, and I multiply them, and then I add them up, right? What I'm gonna get is the number of places where they pick the same team in the same round, okay? So I call that the overlap. Now, if the overlap is like 64, they're the same bracket. If the overlap is 0, totally different brackets, I'm gonna let that number be flexible. So I'm gonna call that number gamma. That's like my diversity parameter, okay? And just make sure the product of my bracket and the last bracket is less than gamma for all the last brackets, okay? So that's diversity. That's gonna give me a whole bunch of different brackets, not gonna be the same thing, okay? All right, so now I think we're ready to roll. So that's the whole integer program. So yeah, take a picture if you want for your, whatever you're doing in March, okay? Cameras are up. That's right, get a picture, zoom in, high-res stuff. Yep, okay. I want to class people, come on, wrap it up, let's go. If somebody post it on Twitter and like share it. That's the actual code. So when you want to code this thing up, that's the code. Maybe this is more important for you people. Yeah, get a picture up. I'll give you like 10 seconds with that picture, right? Yeah, that's the whole thing, by the way. That's crazy, right? You give me the Q, and that's the whole code to make all the brackets you want, right? That makes 1,000 brackets, 1,000,000 brackets, whatever you feel like. You good? Okay, I see cameras down. All right, so that code is in a language called Julia, all right? Now, Julia was built at MIT, and it's very near and dear to my heart because I use Julia to actually win DraftKings and make a ton of money there. Julia was built by my colleague, Professor Zaman. He's like the OG of integer programming. He's the GOAT, right? Those are students that built it with him, and they're jumping because the thing's called Julia Math Programming. So jump, clever, right? Yeah. So jump. So Juan Pablo, amazing technology that just like changed my life. You know, like I play DraftKings every single day. I'm playing today actually, because I'm addicted. So thank you, man, for feeding my addiction. Okay. So there is one thing we gotta fix, okay, people? So remember last year when like in the first round, a lot of y'all are groaning because your bracket got busted in the first round when Virginia like lost to UMBC. Like that was such a crazy upset. It's so crazy, I don't even know what UMBC is. I had to Google what is that place, right? It's like University of Maryland, Baltimore Police, I don't know, something like that, right? But that happened and that broke a lot of people, okay? I'm not gonna get broken. So I'm gonna handle that situation. Here's how I handle that. I'm just gonna add noise to my prediction. I'm literally gonna take my prediction, right, that I worked so hard to build, and throw crap on it, right? Just make it like a turd of a prediction, a big rotten turd, stinky turd, right? Like for instance, if I think that Virginia is gonna win the game with a 99.9% chance, I wanna put some crap on the prediction and make it a 40% chance. Now you might think that sounds ridiculous, but then that happens, so who's ridiculous now? You know what I'm saying? You don't know a turd's a turd, half a turd is done, okay? So we'll sprinkle it all over the place, and that's it. So we're gonna take my original P matrix, right? And then I'm gonna add some noise to it, make a new one. Then I'll add another noise to it, make another one. Add random noise like this, boom, 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 make a bunch of these P matrices, okay? And then everyone's gonna give birth to a bunch of these brackets, right? Just like I showed you before. And I found what works best is like, write this down, about 20 brackets per P seems to be a good one, because then you can solve it really fast. So 20 brackets per P, it'll take you about, I don't know, a second or 2 seconds to make 20 brackets, right? And then make as many as you want, right? And making P noisy is really easy. Adding noise to P like takes no time at all. So this is really, really fast, like insanely fast, okay? Okay, so that's how it works, okay? It's all the mathematical details. It's actually kind of simple. Like, my colleagues at MIT think it's kind of stupid because it's so simple. Like, Juan Pablo's embarrassed to, like, write a paper about it with me because, like, man, my people at Integer Program will laugh at how simple this thing is. But I'm like, dude, but it works. I mean, okay, let me show you it works, and I'll say it works, okay? But it does work. So yeah, does it work? It does work. All I want to be here. Okay. So if we played in 2017, okay, the best score there was 1760. We entered 500 brackets in our like back tester, and we got 1660. So that year we would have come in 50th place out of 25 million. Hey, not bad, right? I mean, I didn't win, but not bad. 50 out of 50 million is like the best of the best of the best. Is it 3 bests? I think so, right? Yeah, I'm Top Gun, right? If you're wondering, the dorks out there, this is the parameter configurations that make it work. So we tried a bunch of different configurations. Sean did. So like different overlaps, different noise, standard deviations. So when you add the noise to the P matrix, you have to like pick the noise variant, like how much crap to put. So it looks like making a noise of like 0.8 or 0.9 or something like that. An overlap in the mid-40s seems to get you a good trick. Like check out the best bracket for all the configurations. It's about the same, 60 to 40, 60 to 50. Okay, so mid-40s overlap, about a 0.8, 0.9 noise standard deviation, run that thing and you're good to go, okay? So we tried again the following year, the year of the bracket buster, and we would have won last year, god damn, right? So sometimes you just miss the boat. So yeah, so last year we would have had 1720 points, the winner that year had 1670 points. You know why we won? Because I had crap with the matrices. So you thought it was crap, but I had a winner there, right? I picked that upset in one of the brackets, right? Most of the brackets were crap that year for me, but that one guy made it. Feel me? And if you look at the parameters, same kind of thing, right? Like mid-40s for the overlap, and like 0.85 seems to be the trick for the standard deviation. Okay? So that's it. So just to summarize, next, I want to win this thing in 2019. So I built an army right now. We're trying to do this together. Really, we have the brackets built. It's just like we got to get them in the contest. So a lot of our work is like kind of crowdsourcing this task out. So if you want to like join the MIT Madness Army, hit me up, Twitter, Zilisto, email, zilisto@mit.edu, and then let me know your email, and I'll help you. Like, you can create an ESPN account, and they'll give me some brackets to enter them. But this is like a team effort, people. Like, one person can't win this, we're gonna win this together. All right, so if things work out, we can have another bracket bust this year, and I think we'll come on top. Okay? All right, so I'll stop there because I expect some questions. So we got about 10 minutes for questions. So you can clap now. Okay, let's get into some Q&A now. Yes, you kind, sir.
The winner for you for last year was in 500 brackets. What if you use only 50 brackets?
Okay, the question was, that's with 500 brackets. If I picked 50, like how'd the best one do? I think the best bracket that got that score was buried somewhere in the mid 200, 300s. So actually it is in the top, because it's noisy, right? So same thing in DraftKings. Like the winner that gets me all the money is usually in the middle somewhere. It's not the first or second lineup. Yep. Okay. Next question. Oh, no questions? Damn. I like rush to get questions, because like I get a lot usually. One over here.
Do you actually have anything, so like Virginia versus UMBC, you start with VA having the 99.9% chance, do you just use the odds, or what odds do you use?
Okay, so the question is, how do you get the noisy prediction from the baseline prediction? So the baseline is maybe like an ELO model or something reasonable, right? I have a reasonable model, and then that's a probability, right? It's between 0 and 1. So what I do is I take the logit of that number, which is the log of that number, divided by 1 minus that number, okay? That makes it cover like the whole real line. Then I add the Gaussian noise to it of 0 mean and the variance, I guess, of 0.85. Then I invert that transformation to get back a new probability that's like crazy, right? That's how you go from 99.9 to like 0.4, right? You transform it, add the noise, transform it back, good to go. Is that clear? Awesome. Yes?
Can you apply similar techniques to lottery?
Okay, the question is, can you apply this to lottery? Okay, let's think about it. So in lottery, I can enter as much as I want, okay? The huge payoff, cool. But I don't have a really good predictive model, right? Like, what is the chance of this ticket winning and that ticket winning? As far as I know, maybe I'm missing something here, they're all the same, right? You just pick random numbers. Here, I have a slight edge, right? Like, I kind of know the good teams and kind of the bad teams. It's a slight edge, right? Like, I'm not Nostradamus here, but with a slight, like with a turd projection and my algorithm, I can make gold, right? So in lottery, I don't think you have even a turd. You have just like diarrhea. Like, it's nothing, right? There's nothing there, no structure. So I don't think it'll work for lottery. Okay? Yeah, it's right there.
For 2019, are you using the 538 kilo for your team?
Yeah, I don't do that stuff. Like, we got our own, but I mean, the thing is, the model's so robust, I could probably use his model and still win. Like, it's that good, right? You can even survive a Nate Silver projection. So, yeah, you can totally use it. Okay. Yeah, so we tested like every parameter value to test it out. It took a long time, and like Sean got kind of busy with like undergrad life, so we just got a chance to check like 2 years. I think he's checking back earlier years now, but now it's like game time almost. We gotta get going, so we'll just try it out, see what happens. Yes, over there.
Why do you think the noisy thing works? It seems like it shouldn't. And do you think it's just it's just helping you account for the other brackets, which you're not accounting for, which would probably help?
So the question is, why does that noise trick work? Like, why can't it just like make more and more brackets and be diverse and work? And the problem is that to get that upset, which was Virginia losing to UMBC, right? You got to get to like bracket 50,000 probably, or 60,000. When computing the brackets, you get to like bracket 300 and it starts slowing down. Like making it different from that many previous brackets just takes forever. So this is just like a faster way to get to like that kind of diversity, right? And honestly, when I tried it, I was just trying something because I know in machine learning, they try this a lot to add noise and stuff, and it seems to work. So I said, okay, try it here, why not? And it worked. So as an engineer, I'm like, well, it works, so let's roll with it. It's easier, it does the same thing as like diversity, so let's use that. Okay, is that okay? Cool. Got a hand way back there. In the black shirt.
Yeah, could you apply this concept to like low probability
Yes. The question is, does this technique work for parlays, which is like you bet on like 5 games at once, and if all 5 games win, you get like a ton of money. So I checked Bovada, right, how parlay odds are paid out, and they kind of like match the baseline odds, right? So it's as if they're independent. So I don't think it'll work there that well unless you know something. There's like a correlation hidden in there that Bovada or the bookies aren't like modeling. For instance, I heard like in college football and like conference games, usually it's like a very, very high scoring game, higher than usual. So you can do parlays on like maybe the total score in a conference game in college football. Maybe that's not factored in there. But other than that, it probably wouldn't work that well. So if you know something about some kind of correlation that they don't know about, yeah, totally use this thing. Okay. In the middle, the back.
Yeah, have you considered factoring the popularity of other people's teams and other people's brackets?
So the question is, have I considered what everybody else is doing and like decide my brackets with some, try to avoid what they're doing? So I haven't tried that, although I saw a paper by some professors, actually cite my paper, that tried to do that for DraftKings. And they said it seemed to like improve their performance, although they didn't win like $50,000 I did, so I don't know how much better it is. Okay? But it is probably like next step in this. But to be honest, I feel like this will get you there, and then I wouldn't worry too much about it. That's my feeling, but I could be wrong. Yeah.
How do you value the returns on each additional bracket? Like, if you have to pay $5 per bracket, how do you determine how many?
Yeah, so I've never really thought about this too deeply because in DraftKings, they like upper bound you. It's like 150 lineups and you're stuck here. And then here it's like, it's essentially free to enter the ESPN contest, so I guess there's nothing stopping them from making tons of brackets. But to really like evaluate it, my kind of rule is like, you gotta figure out what's the chance you're gonna win, like when your guys is gonna hit, right? And then how much money you get if you hit. So if you think like with your brackets, you have like a 1% chance of winning, right? And then it's like X amount of dollars, right? Minus the cost of entering them. That calculation. The problem is like that probability is hard to figure out. What's the probability I think it's gonna work? I don't know, right? So I just kind of do as much as I can and then see what happens. I have to explore that question really deeply. The place I tried it wasn't a big deal, right? DraftKings in here. Yes.
So I think it's on ESPN every year that they do like the 8 teams that could possibly win. So when you sprinkle your turd dust on it, does it result in a lot of different teams winning more so than maybe you would expect?
So when I sprinkle the turds on it, like so if you're like 100% sure you're gonna win, right? Then when I take your look, it'll take me to like maybe 10, 20, that kind of value. Then I add a noise of a variance of like 0.85, let's say one variance. We go from like 20 to like, like 18, maybe 16. I'm making a lot of things, right? And invert 16, you get something like a little bit lower. Yeah, so it'll like push them, like it'll make them reasonable, right? It'll not be like 9 up, but not be like 85. Because it'll still be good, but like not as confident, right? That's all it's doing. Any more? We got 2 minutes, people, so we can keep poking in here. Yes.
Are there any like really big contests like this one where you get extra points for upsets? Because I'm sure when you change your bet function, you crush everyone else a lot.
Yeah, so I've heard about these upset points. To be honest, I never like studied it that deeply, and I'm guessing those kind of tournaments aren't as big as ESPN, so I can't enter 1,000 brackets in all those tournaments. I don't know, but that's my assumption. So yeah, it'd make it more interesting, I suppose, but if I was playing, I'd just do what I'm doing here and apply it there blindly. It might be okay. But yeah, I hadn't thought about that question yet, but a very good question. Anything else? Yeah, way in the back there.
You mentioned like not to go for the lottery, maybe for parlays, I don't know. Any other applications that you get for?
Yeah, so funny you mentioned that. So when I first did this work at DraftKings, right? My Sloan colleagues, who are like esteemed business school professors, yelled at me because they said to me, "What kind of paper is this?" I said, "It's about playing DraftKings." "Are you playing a game?" "Yeah, it's fantasy sports." "We don't play games at Sloan. We don't play games at Sloan." He's banging my table in my office, scaring the crap out of me, right? So he said, "Oh, that's not good." And then you fast forward like 3 months after I won $50,000 in DraftKings baseball. And then like we're down in DC in the airport, meeting, and like I got my DraftKings book bag on, and the guy in the airport goes, "Yo man, do you work for DraftKings?" I go, "I just play it." "Yo, my brother-in-law won 100,000 in golf last week." I said, "Word? I won 50K in baseball 2 weeks ago." "Yo, nice man, nice." And then the colleague goes, "Tauhid, You won 50,000 in DraftKings? This is a home run. This is a great paper. This is amazing. You can apply it to innovation, things like that. I said, yeah, you're right, maybe I should. And so we applied the same kind of thinking to actually venture capital investing. I wrote a paper about that, where we call it picking winners in venture capital. And like we can actually build a portfolio like 10 companies and like 6 of them have an exit. So the same kind of picking winners thinking actually applies to like a real setting. But to be honest with me and you, like I have more fun doing this than like venture capital, but we did that paper or whatever for academia. But this is like where it's at. But it can be applied to other things like investing in innovation, investing in cancer drugs, research projects, any kind of like, home run kind of situation. I got 20 seconds left, so who wants to ask the last one? Who is so brave? Yes?
What are you gonna do with the money?
Oh, so it ain't about the money. So like when I won the DraftKings in hockey, I gave $20,000 to the Boston Food Bank. So if I won the March Madness, I got students to take care of, so I'll see what they want to do, but if up to me, I wouldn't care. Just give it away. I don't care. It's more about just doing it, right? That's more fun. I got plenty of money. Who cares about that? Right? It's about winning. I want to win. I want to beat W. I got those. I got those. I got all the X's. All right, I think that's my time. So thank you.